Good morning, students. Today we are going to see about a simply supported beam with uniformly distributed load as well as point load. For this case, how to calculate shear force and bending moment values. By using that values, how to draw the shear force diagram and bending moment diagram. So this is the case that we are going to see today. In this slide, the first diagram shows the simply supported beam of span 9 meter carries a uniformly distributed load of 20 kN per meter over entire span. Also, it carries 2 point loads of 40 kN each, acting 3 meter from both the supports. The first step is we have to remove the support and apply the reaction. Since this is the simply supported beam, for this case they have given one roller support and one hinged support. As already we know about support reaction. So roller support has one reaction, that is vertical reaction, and hinged support has two reaction. One is horizontal, as the another one is vertical. So the second diagram shows the simply supported beam with the support reactions. The first step is to find the support reaction by using equilibrium equation. This already we have studied in our engineering mechanics, but this is the very important step as far as the shear force and bending moment is concerned. If the support reaction value is correct, then the next step will be evaluated. If the support reaction is wrong, there is no need of evaluating the subsequent steps in the examination. So all must know about support reaction very clearly. We are going to solve the support reaction by using equilibrium equation. The equations are summation h equal to 0, summation v equal to 0, summation m equal to 0. That is sum of all the horizontal forces in the beam is equal to 0. Sum of all the vertical forces in the beam is equal to 0. Sum of moments of all the forces about a point in the beam is equal to 0. These are all the three equilibrium equations. The first one is summation h equal to 0. Since the beam has no horizontal forces, so there is no need of using this equation. So next we are going to use the summation v equal to 0. That is sum of all the vertical forces in the beam is equal to 0. So here the vertical forces are 2 point loads, 1 UDL and 2 support reactions. We are considering upward is positive, downward is negative. So plus VA minus 40, that is first point load, minus another minus 40, that is second point load, and then minus 20 into 9, that is the uniformly distributed load, total load of uniformly distributed load, and then plus VD, that is another support reaction, that is equal to 0. So VA plus VD equal to 260 kilonewton. So generally in simply supported beam, if you add there is two support reactions, vertical reaction, that will give the total load on the beam. This is the simple concept. The next equilibrium equation is summation MA equal to 0. That is sum of moments of all the forces about point A is equal to 0. So moments means force into perpendicular distance. So whatever are the forces that you have written in the summation V equal to 0 equation, we have to multiply the force with the corresponding distance. Here we are taking the moment about point A. So VA is acting on the point A itself, the distance is 0, and 40 kilonewton point load is acting 3 meter away from the point A, and another 40 kilonewton point load is acting 6 meter from point A, and the uniformly distributed load of 20 into 9 is acting 4.5 meter, that is 9/2 distance from point A, and then the another support reaction VD is acting 9 meter from point A. So VA into 0 plus 40. Here we are taking up clockwise is positive, anti-clockwise moment is negative. So VA into 0 plus 40 into 3 plus 40 into 6 plus 20 into 9 into 9/2, that is for UDL, minus VD into 9. So here the support reaction VD is giving the anti-clockwise moment. So we have used negative sign equal to 0. So by solving this equation, you will get the value of VD equal to 130 kilonewton. If you substitute the value in the previous equation, that is VA plus VD equal to 260. If you substitute the VD value as 130, you will get the value of VA, that is 130 kilonewton. So both support reactions are equal since the beam is carrying a uniform loads as well as uniform equal distance. So next step is we have to find the shear force and bending moment for each points in the beam. So by solving this, so to find the shear force and bending moment, we must know about the sign conversion. So left side upward, right side downward is positive, left side downward and right side upward is negative in case of shear force is concerned. Left side clockwise, right side anti-clockwise is positive, left side anti-clockwise, right side clockwise is negative in case of bending moment. So as already we have discussed about what is meant by shear force and what is meant by bending moment. Again here I am repeating this. Shear force means algebraic sum of all the vertical forces either left or right side of the section. Where we want to find the shear force, we can consider left of the portion or right of the portion. We have to add all the vertical forces either left or right side of the section that will give the shear force in the particular point. So similarly for bending moment, the algebraic sum of moments of all the forces either left or right side of the section. So by understanding, we are drawing the left portion of the beam, each point of the beam. Okay, so first point is A. There is no portions available in the left side of the beam, so only point A. In the point A, 130 kilonewton reaction is acting in the upward direction. So shear force at A plus 130, that is upward, left side upward. Bending moment at A 130, there is no distance, that is 130 kilonewton is acting in A point itself, there is no distance, that is 130 into 0. So here I have drawn the left portion of B. Now we are moving into the point B. We are going to find the shear force and bending moment in point B. So I have drawn left portion of point B in the beam. We have to consider the beam. We are coming to point B. You have to draw the left portion and also the loads available in the left portion. So here one support reaction and uniformly distributed load and a point load of 40 kilonewton is acting in the B point itself. So here you have to keep one thing in your mind. If there is a point load at the end of UDL, not starting of UDL, at the end of UDL, in shear force, we have to calculate two values. One is without considering the end point load. The second one is with considering the end point load. So that's why I have mentioned here as shear force B at B, that is shear force B1 and shear force B2. In shear force B1, that is plus 130, that is upward direction, minus 20 into 3, that is UDL is acting 3 meter for the left portion of B. So 20 into 3 will get plus 70 kilonewton. The shear force B2 is by considering the point load it's also, that is plus 130 minus 20 into 3 minus 40, that will give plus 30 kilonewton. That is, this is for only for shear force, not for bending moment. So again I am telling that you have to keep one thing in your mind. If there is a point load at the end of this UDL, you have to find the shear force value, two values. One is without considering the point load. The second value is with considering the point load. Okay. Now bending moment at B, that is 130 kilonewton is acting 3 meter from B. So 130 into 3, that is creating clockwise moment, and the UDL is acting 20 kilonewton per meter for a distance of 3 meter, that is 20 into 3. The total load is acting at the point of 3 by 2. That point is also 1.5 meter from B. So 20 into 3 into 3 by 2. That will create a negative bending moment, that is anti-clockwise moment. Also 40 kilonewton point load is acting at a point B itself, that is no distance, that is 40 into 0. You will get the bending moment value of plus 300 kilonewton meter. So similarly for point C, you have to draw the left portion of the point C. Here also at the end of UDL, we are having point load. So as already I have told that if a point load is at the end of the UDL, you have to find shear force value, two values. One is considering point load, sorry, without considering the point load. The second value is considering the point load. So here plus 130 minus 40 minus 20 into 6. So here in the left portion of C, UDL is acting about 6 meter. So I have mentioned as 20 into 6. You will get the value minus 30 kilonewton. The second shear force C2 is considering the point load. So minus 30, in addition to the minus 30, you will get minus 40. That is minus 70 kilonewton. That is 130 minus 40 minus 20 into 6 minus 40, you will get minus 70 kilonewton. So bending moment at C, 130 is into 6 minus 40 into 3 minus 20 into 6 into 6 by 2 minus 40 into 0. This also will get the value of plus 300 kilonewton meter. And the last point is D. Here we are taking up right portion of the D. In the right portion there is no beam, only D point is there, and our reaction of 130 kilonewton is acting at D in the upward direction. Right side upward is negative. So shear force at D is minus 130 kilonewton, and bending moment is, there is no distance, so bending moment value is 0. So far we have calculated the shear force and bending moment values. By using the shear force and bending moment, how to draw the shear force diagram. In the shear force diagram, we are going to use only 3 lines. One is horizontal, one is vertical, another one is inclined. If there is no force between 2 points, we have to use horizontal line. If there is a vertical force, we have to use vertical line. If there is uniformly distributed load or uniformly varying load, you have to use inclined line. Okay. So if the vertical force is in upward direction, the line should be from bottom to top. If the vertical force is in the downward direction, the line should be from top to bottom. This is the concept that you have to keep it in your mind while drawing the shear force diagram. So at point A, that is plus 130, and that is shear force at A. Shear force at B1 is plus 70, B2 is plus 30. Shear force at C1 is minus 30, C2 is minus 70, and then shear force at D is minus 130. You have to connect all the values, all the points by the line, by using lines. So already I have mentioned that we have to use vertical, horizontal, and inclined lines only. So at the point A, there is upward reaction. The line is going from bottom to top. From 130 to 70, we have to, I'm using inclined line, since there is the beam between A and B. In the beam between point A and B, UDL is there. So I have connected these 2 points by using inclined line. At the point B, there is a sudden point load is acting. So line is coming from 70 to 30, that is from top to bottom, then the downward direction. Again UDL is acting, again point load, again UDL is acting, and finally upward reaction. So the center horizontal line is considered as a 0 line. The positive values should be marked above the baseline, and negative value should be marked below the baseline. So this is your shear force diagram. The next one is bending moment. Bending moment at support points is 0. So here in the shear force, sorry, in the simply supported beam, the bending moment at support point is always 0. And the point B is 300 plus 300 and also point C plus 300. Since the entire beam is having uniformly distributed load. So in the bending moment diagram, you have to keep one thing in your mind. Here we are going to use only two lines. One is inclined line, another one is parabolic line. So since the entire beam is having uniformly distributed load, we are connecting the points by using parabolic line. So here one thing we can see in a point between B and C, the shear force value is getting 0. That is, shear force value is coming from positive to negative. That means at a particular point, the shear force value is 0. The one concept that you have to keep it in your minds, where the shear force value is 0, there the bending moment value will be maximum. Where the bending moment value is 0, there the shear force value will be maximum. That is, shear force and bending moment are in vice versa. If shear force is maximum, bending moment will be 0. If the bending moment is maximum, shear force will be 0. This is the thing that you have to keep it in your mind. Hope you all understand the concept. If you are understand the everything, you can solve like the problem by changing the values. So in this problem, we have used 20 km per meter UDL. So change the 20 km per UDL into 18 km per meter, and instead of 2 point loads, that is 40-40, you can change the values. That is first 40 kilonewton as 55 kilonewton, the second 40 as 35 kilonewton. You can solve the problem and upload the your solution in a PDF format in CMS. Thank you.